Good day and welcome to Big Bad Tech. I'm your instructor Jim Pytel, and in this short application exercise, we'll learn to configure the Omron 3G3JX-AE004 motor drive for jogging operation. This lecture is predicated on the assumption that viewers watch both the configuring multifunction inputs and 3-wire control forward-reverse circuit featuring the Omron 3G3JX-AE004 motor drive lectures available at the Big Bad Tech channel. If you haven't watched these lectures yet or only dimly recall their contents, please take the time to do so now. Additionally, since we'll be dealing with this particular manufacturer's parameter programming process and navigation within it, it may help to download the associated datasheet and/or user manual. In the previous application examples featuring the Omron 3G3JX-AE004 motor drive, recall we configured this drive for a proper sourcing arrangement by placing a shorting bar between terminals PSC and SC. Please do not forget this important step. Additionally, recall we hardwired a normally open maintain contact selector switch as input 1, a normally closed momentary contact red push button as input 2, a normally open momentary contact green push button as input 3, and a normally open momentary contact yellow push button as input 4. Given we've already wired up this associated hardware, we can simply reprogram the input to perform different functions. Note this simple functional reassignment really highlights the utility of motor drives. A couple simple taps in the keypad allow completely new functionality without the time-consuming necessity of rewiring it. Recall that the previous application's exercises examined only a handful of the numerous available functions, namely 00 forward, 01 reverse, 21 3-wire stop, 20 3-wire start, and 22 3-wire forward reverse selection. Recall that forward and reverse act similar to a 2-wire control circuit, in that the motor is energized in the direction of choice only when that particular input is actively being asserted. The 3-wire functions, in contrast, maintain or remember the last asserted state. All of these functions, you'll note, result in full speed operation of the motor if given enough time to complete the acceleration period. Let's expand our repertoire by examining the jogging function available on the Omron 3G3JX-AE004 motor drive. Jogging, or inching, you'll recall, is the momentary excitation of a motor for the purposes of partial or brief movement of the shaft. Jogging using electromechanical contactors is discussed extensively in the Motor Starters with Jogging lecture available at the Big Bad Tech channel. You'll recall that jogging using an electromechanical contactor is the harshest of experiences, necessitating an electromechanical contactor make and often break inrush current. Additionally, the jogging experience making use of a primary voltage source with a fixed excitation frequency is characterized by a rapid acceleration of full speed and an extremely imprecise stop, often necessitating the inclusion of a spring-applied electrically released friction brake to increase accuracy. If the constant speed mode is to be likened to driving a car on a highway between two distant cities at full speed, the jogging action can be likened to a short trip between neighboring houses or parallel parking in a busy city. The fundamental flaw with jogging operations conducted by electromechanical contactors making or breaking contact with a primary voltage source with fixed excitation frequency is that even the smallest movements occur at full speed. Returning to our automobile analogy, zooming around the neighborhood in parallel parking at 60 miles per hour may yield less than desirable results. For this reason, most motor drives offer the ability to perform slow-speed jogging in which excitation frequency and applied voltage are substantially reduced in comparison to full-speed operation. Excitation frequency has a direct relationship with rotational speed, and if excitation frequency is substantially reduced, the jogging action can be performed with far more control and accuracy than previously. This would be analogous to slowly cruising around the town at a reasonable speed, much to the delight of neighborhood children and pets that make it a regular habit to play in the road. The Omron 3G3JX-AE004 motor drive offers this slow-speed jogging experience and is customizable using several related extended function parameters, namely A038, jogging frequency, and A039, jogging stop selection. Extended function parameter A038, jogging frequency, as the name implies, is the frequency at which the jogging action occurs. This has a default value of 6 Hz and is user adjustable up to just shy of 10 Hz. Jogging with the Omron 3G3JX-AE004 motor drive therefore can be thought of as not only brief excitation of the motor for the purposes of small movement, but also as slow and purposeful, precise movement enabled by the speed control aspects of the motor drive. Given a linear volts per hertz relationship, applied voltage at reduced excitation frequency is also proportionally reduced. Note when jogging is enabled, there is no acceleration ramp up to the jogging frequency, but rather quasi-instantaneous step-like acceleration to the jogging frequency. This being said, it's still substantially less harsh in experience than jackrabbiting from 0 to 60. Extended function parameter A039, jogging stop selection, offers 3 options, all detailing the different methods used to decelerate after the jogging action. 00, the default state, is free spin to stop. 01 is deceleration ramp down. 02 is DC injection braking. The free spin to stop, as the name implies, simply depowers the motor after the jogging action halts. If unrestricted, the shaft would continue to coast to a stop. However, given jogging occurred at a substantially reduced speed, the coasting action would be relatively brief. Accuracy of the jogging action followed by a free spin to stop could be significantly increased if a spring-applied electrically released friction brake was coordinated with the run state of the drive. Additionally, the spring-applied electrically released friction brake could be used to lock the de-energized motor in place. Deceleration ramp down is an almost worthless feature following a slow-speed jogging event, given no great speed has been achieved in the first place. This being said, this option is available for those that wish to experience its utter worthlessness and heap scorn upon it, as do I. On the extreme opposite end of the worthless scale is a DC injection braking following the jogging action. This is an extremely cool feature because it is a non-contact means of deceleration. DC injection, if you recall from the motor drive deceleration methods lecture available at the Big Bad Tech channel, is the momentary application of fixed DC to the stator windings, which fixes the ordinarily rotating magnetic field in place. The rotor then tries to align itself with the fixed magnetic field and decelerates without the necessity of physical contact. While DC injection braking cannot positively lock a rotor in place as can a friction brake, it however can provide limited holding ability.